we know how to draw up the basic trig functions, just sine x, cos x and so on. But of course it might not always be just x. So let's recap. Here's our sine curve. Now we know it has an amplitude of 1, so I'll mark that in on the y-axis. And normally I would mark off every 90 degrees, but we're using radians now. So I'm going to mark off every pi on 2, but you'll notice I got lazy there because it's a hassle to write pi on 2, so I only labelled every pi there. But it is marked off every pi on 2. Sine curve, we start at the origin, then we go up, and then we have that zigzagging pattern all the way up and all the way back. But of course it's not like when we're back in kindy and we're playing dot to dot and we draw it with nice sharp lines. It's a smooth curve. So there's the basic y equals sine x in radians. Okay, interesting features, domain, all real x, the range in between -1 and 1. It has rotational symmetry. So we do know it is an odd function. Odd function. One of the other things we're interested in is the period of our trig curves. And a period just basically means how long does it take to get back to the same point, but in the same direction. Now I've drawn it at the peak here, so it's not a big deal. But if you look at an x-intercept, it looks like it only takes you pi to get back to the same point. But notice at 0 we're going up or increasing. At pi we're going down or decreasing. So we have to be going in the same direction as well. So it doesn't matter which point you pick on the curve, it takes 2 pi. So the period is 2 pi. Amplitude, of course, is how high up it goes. Now, we could be wanting to draw any sort of trig graph. So we could have some shifting happening, some stretching happening, all those sorts of graphing ideas that we saw last year. So to generalise it, we're only going to be looking at drawing linear functions, so certainly in 3-unit level anyway. The period will always be 2 pi divided by the coefficient of x. So whatever the coefficient of x is. Amplitude will be the coefficient of the trig function. But the other thing I like to work out are the divisions, because I know I'm going to mark off. The key features happen on our basic one, every pi on 2. But basically it'd be whatever the period is divided by 4. So I work that out so I know where to mark my divisions off. If I'm only drawing one graph, I could draw the same graph every single time. I just change the label on the intercepts there, and you got the same graph. Shifting would be C over B, because the horizontal shift, remember, is when it is grouped with the x. So C by itself there is not grouped with the x. So if you were to factorise that so that C is grouped with the x, you'd actually have B outside of x plus C on B. So the shift is actually C divided by B. So let's go crazy. We're going to draw 5 sine 9x minus pi on 2. So the period would be 2 pi on 9. I know the amplitude will be 5. And I'll just work out my divisions. It'll be every pi on 18 I'm going to mark off. And our curve is shifted pi on 18 to the right. So let's draw it up. And basically I'm going to draw exactly the same curve. It's just that instead of labelling it 1 and -1, I'm now labelling it at 5 and -5. And on my amplitude, instead of marking in pi, I've got pi on 9 and 2 pi on 9 and so on. The other thing I've got to take into account is the shift. Normally I would start this at the origin, but we're shifting that pi on 18 to the right. So I will start over here at pi on 18. But then the same pattern happens. I go up, and then we do our zigzag, and we get our same sine curve. Now, if they had said draw this for the domain minus pi on 9 to 2 pi on 9, technically I've drawn it wrong. I should have stopped. Can't do that in PowerPoint, because if I was stopped there, it would give a sharp thing. I need to keep going to get the curve of the shape. So that's why I've kept going on mine. But when you're hand drawing, obviously stop at the end of whatever domain they've asked you to draw it for. Okay, the cosine curve is of course exactly the same as the sine curve. It's just shifted. So the same things are going to happen. If I've got a cos bx plus c, period will be 2 pi on b. That'll be the same. Amplitude still be the same, a the divisions will still be the same. The shift will still be the same. The only difference is, of course, where we start. Instead of starting at the origin, we start at the amplitude for a cosine curve. So let's draw, oh, look at this one, minus 4 cosine x on 8 plus pi, all of that plus 2. All right, period. Period's going to be 16 pi. 16 pi. Amplitude's going to be 4. I'll mark off my divisions every 4 pi for this one. And we are shifted 8 pi to the left, but also 2 up. But also on top of that, it's upside down because we've got negative 4, not positive 4. So we've got a whole heap happening with this one. So let's draw it in. The first thing I'm going to draw in is actually a horizontal line there. I've just dotted it to indicate it's not actually part of the graph, but it's going to give me somewhere to plot my point, because the axis where we plot those points has been shifted up too. So that's somewhere to plot those points. And the amplitude, well, we'll be going up to 6 and down to negative 2. There's 4 either way. So I'll mark off horizontally on the x-axis. All right. We normally would start at the amplitude, but the amplitude has been shifted up. So I've done the shift up. Then it's upside down, so negative 2, I've done that. So the only thing left to do now is the 8 pi to the left. So yeah, I start down here. That would then go to the axis, and we go up and down from that point. And there's my cosine curve. No, I don't know they're going to get us to draw something as crazy as that, but I mean, it combines every possible sort of shift we'd have there. Yeah. Tangents. Now, differences with the tan curve. Remember, its period wasn't 2 pi, its period's only pi. So for this one, it'll be pi divided by b, not 2 pi divided by b. You'll notice I haven't worried about amplitude, because with the tan curve, it doesn't have an amplitude. It goes down from minus infinity up to infinity. Divisions now, I'll do period divided by 2 instead of period divided by 4. Shift will still be c over b. So we're going to draw, whoa, e tan pi x minus 2 pi. I mean, really, I could throw any number out the front because I'm not worried about the amplitude. The only thing I have to watch out for is if it was negative, then it would be upside down. Okay, the period is just 1. So I'll mark my divisions off every half. And this one we're shifting 2 to the right. 2 to the right. Yep, let's mark them in. All right, my tan curve, I would normally start at the origin, but this one's shifted 2 to the right. Now the pattern for a tan curve goes x-intercept asymptote, x-intercept asymptote, x-intercept asymptote. So I'll put an asymptote over there, then we'll go to the left, and so on.
Oh yeah.
And then we just draw our tan curve.
What the hell? Wait, the 2 pi doesn't. Yeah.
That's right, because its period was 1. So shifting it 2 to the right did nothing, because you've shifted it 2 periods. So you're right, it does still end up being the tan curve.
I didn't realize that.
The E did nothing, because I haven't put a scale on my y-axis. So it's just so really it's just a tan curve. But instead of having pi's and 2 pi's, I've got 1s and 2s.
Wow.
There it is. Now remember, when you're drawing your tan curve, it's not a cubic, so it's not a horizontal point of inflection. It should be coming through at 45 degrees. It should be coming through at 45 degrees. All right, that'll do us.